Okay, good morning everyone. We will go into the next concept, that is common building defects. Okay, what are the general common building defects which are coming under general day-to-day life? See, first we'll see causes of the building defects. Okay, causes. What are the causes? The design and construction flaws. We can carry out this such that design and construction flaws. Okay, so in that, design of concrete structure governs the performance of the concrete structure. Okay, so the design itself is the first cause. If it is good, then total building will be free of maintenance. Okay, so if the design is poor or if it contains some deficiency, so obviously the maintenance will come. Okay, the well-designed detailed concrete structure, a well-designed and detailed concrete structure will show less deterioration in comparison with the poorly designed and detailed concrete. Okay, in the similar condition, the beam column joints, the very important structural part, the beam column joints are particularly probed to the defective concrete because it's a heavily reinforced one. Okay, heavily reinforced, so concrete cannot get into the all the places or corners, so the compaction is not up to 100%. So that is why the beam column junctions are very defective in nature. Okay, so if detailing and placing of reinforcement is not done properly, then beam column joint definitely will show a poor performance. Environmental effect. What are the things will come? In the environmental part, this cause, what is that? Micro cracks present in concrete. Micro cracks present in concrete are the sources of access of moisture. So from these small pores or cracks, this moisture or atmospheric CO2, that carbon dioxide into the concrete, get into the concrete, which attack the steel, which will attack the reinforcement and react with the other concrete ingredients. In the aggressive environment means what? In marshy soil, coastal area, chemicals present in the soil or industrial area, those are called as aggressive environment. The concrete structures will deteriorate faster, and the strength or life of the concrete structure will be severely reduced. Obviously, if exposure to the aggressive environment is there, then concrete structure lifespan will reduce very fast. Usage of poor quality material. Okay, one of the cause for defects. Usage of poor quality of the material to be used in construction should be ensured by means of various tests. So that is why you are going to do the BMT lab test, concrete material test, soil mechanics test. Okay, so all those laboratory will have the testing apparatus, so they will check what quality of the materials, maybe cement, maybe aggregate, sand, steel. Okay, so all those things can be done, which should be according to the IS codes. Their specification limits should be matching with the IS codes. So what are the poor quality material will lead to? So these will lead to alkali aggregate. Alkali means the NO2 present in the cement part. Aggregate means reactive silica. These two are reacting, and sometimes sulfate attack will results, which causes the early deterioration. Alkali aggregate reaction is the cement aggregate reaction, which will lead to the expansion of concrete, that will lead to the cracks or disintegration. Sulfate attack means sulfates present in the soil combines with the concrete products and gives a bulging effect or cracks. Okay, clayed materials in fine aggregate may weaken the mortar aggregate bond. Clay is a sticky material, sticky substance, which will makes the concrete, its what is that, mortar aggregate bond weaker. Okay, and reduces the strength. Next cause will be the supervision quality of the supervision. Construction work should be carried out, as per the specifications. Adherence to the specified water cement ratio controls the strength, permeability, durability of concrete. So very important in the design of concrete structure, water cement ratio parameter. Okay, if it is very good adherence to the specific water cement ratio, so that is why the strength, permeability of concrete, durability of concrete will be controlled. Okay, insufficient vibration, very important. Vibration is not done properly, so the porous structure or honeycombed structure will come, so this will lead to segregation. porous, honeycombing are the poor form of concrete structure. Okay, so excess vibration, these are less vibration will lead to porous, more vibration will lead to segregation. Segregation means separating of material and cement paste one side, aggregates on another side. Deterioration due to corrosion, very very important. So due to the corrosion, what will happen? A rust will form. Ferric oxide, its volume is more, generally more, so the more volume will create stress on the concrete structure, and concrete will suddenly starts cracking. So what will happen? Spalling of concrete cover. Okay, if rusting is taking place, so the ferric oxide tries to increase its volume, so spalling will takes place. Cracks parallel to the reinforcement, so bulging will lead to the cracks. Spalling at the edges, swelling of the concrete. So some of the things which will appear from the corrosion part. Category of building defects. How you can classify the building defects? The defects can be divided into two categories. What are those? Structural defect and non-structural defect. Structural defects in the buildings can be categorized as structural, means load carrying capacity. So cracks in foundation, that is substructure. Cracks in the foundation, cracks in the floors and slabs, okay, that is called a superstructure. Cracks in the walls, that is again superstructure. These are the structural defect. Okay, foundation, floor, walls, columns. Okay, these buildings, these structural defects are due to what? Maybe improper soil analysis. You have not done proper soil testing. One of the reason. Improper site selection. Maybe site may be having groundwater level very near to the basement. Okay. Use of defective material, maybe you are not adhered to the IS codes of materials. Substandard work, maybe you have not done the supervision correctly. Okay, some of the causes for the defects. Most of these structural problems can be avoided by proper designing, proper planning. Okay, the next category is, so that is why some mistake is there, non-structural defect. Okay, non-structural defect, what are those things will come? Non-structural defects include brickwork defects, one thing, dampness in old structure, okay, defects in plaster work. So some of these are brickwork defects, old structure dampness, and plaster work defects. Okay, non-structure, these don't carry the loads, but they are good for durability. They are important in the durability aspect. It can be concluded that design and construction defects at the least can cause minor cracks and spalling lead to the concrete deterioration. At the later stage, concrete will start deteriorating, may become the source for major failure, may become failure. Therefore, great deal of attention and care is required in designing. Detailing means dia, spacing of the bars, and construction, three parts: design stage, detailing stage, construction means supervision and construction stage. Okay, occurrence, how it occurs. Occurrence of the building defects. Defects in the building design itself, building design defects. Inadequate design means concrete is exposed to flexural and shear stresses that are greater than its design strength. Let us say you are going to design the M40 grade concrete. So its tensile strength or flexural strength will be generally 0.7 times the square root of FCK. That means 0.7 times square root of 40. So let us say it is 5 Newton per mm square. 5 Newton per mm square. What is that? Its design strength. Design strength in which case? Design strength in flexure case. By applying the load when the concrete structure is under operation, the external load will create some external stresses, maybe flexural external stresses or external shearing stresses. Those values may be more than 5. So that time what will happen? It will leads to the cracks, it will leads to the deflection, it will leads to the deformation. Okay, so that concrete design strength should be designed in a proper way. That is called, comes under which part? Structural design part. Okay, all that leads towards spalling and cranking. Obviously, flexural stress or shearing stress are more than the strength. It will lead to spalling and cracking of the concrete. Okay, an abrupt change in the cross section, wherever some cross sections are reduced, maybe column, maybe at the basement level you have what is that, 400 by 400. At the third floor it may be 250 by 250. What will happen, it there, that intersection part, there will be sudden increase in stress concentration. Do you understand this part? Wherever cross section is changing, whenever there is abrupt change in the cross section or any other member, which will lead to increase in stresses, it will lead to increase in stresses. So the concentration of that stresses will be more, and ultimately it will lead to what? It will lead to cracking of the concrete. It will lead to cracking of the concrete. Deflection is the major part. Deflection is the one of the major part in the design part. So always the L by D ratio, span to depth ratio, it should be continuously checked, okay, with respect to what IS serviceability limits, collapse limits, all those things are there. So what to do? Deflection is very important. More deflection will lead to the cracking of concrete, and it will give unsecured feeling to the users. Okay, if there is any problem in its consideration during the design, that can lead towards the cracking of concrete. If deflection is not within the permissible limits, obviously it will lead to the cracking of concrete. So these are what serviceability criteria, no, serviceability criteria of concrete structures. Inadequate provision of drainage. Okay, you are not provided drainage at the roof level, slab level. Okay, expansion joint during the design also becomes the cause of deterioration. What will happen? The dust particle, fungus, algae, that water moisture is present, it will give to the breeding of mosquitoes. Expansion joint means what? There is a small groove cut such that during the summer season concrete will expand. Okay, so during the design also becomes the cause of deterioration. Defects during construction. What are the defects during construction? Defects during the building construction can range from that concrete mixing. Improper mixing will lead to the defects. Placing of concrete means what? Falling from the height, pouring from the largest height. Okay, all those things can be lead to the defects. Curing of concrete, at least 14 days, 21 days for the respective concrete elements should be done. If curing is not done, the heat of hydration will be more, and it will draw the water from the inside concrete, so the cracks will start coming on the surface. So defects during the construction. Removal of shoring and formwork is another cause of production of cracks. Okay, during the construction stage, let us say you are constructing a slab. Suddenly, within before 10 days itself, you are starts to remove the shoring work or formwork work. So the concrete is not fully set. So that time, what will happen? It will lead to the cracks. If additional water is added in concrete in order to increase the workability, very bad thing in the concrete construction mechanism. So more water you are adding to get more workability, water cement ratio will be increased. More water cement ratio means more capillary pores, more water pores, okay, which are present in the concrete. These are nothing but air voids. Later on, these will reduce the strength. So there only starts get the cracks. Improper alignment of formwork. Okay, one support is a larger number, one support is shorter in the length, so improper alignment, okay, will lead to what? Erosion of concrete. Suddenly starts, the concrete will start defective in nature.